Welcome back, students. In this section we are considering the position vector, then displacement vector, and after that we have to consider the addition and subtraction of vector, then resolution of vector. In this addition and subtraction, two methods we are discussing. One is the graphical method and the other one is the analytical method. Okay, let us consider what is this position vector. The position vector, that means position vector of an object, means in order to represent the position of an object with respect to a selected or a fixed origin, we are using this position vector. For example, if we are considering this xy in a xy coordinate system, then in order to represent the position, let us considering an object at this point P. Then in order to represent the position of this object with respect to a fixed origin or a fixed reference point origin O, we are using this position vector OP. Just join that point O with the point or the position of that object P. And now this OP represent the position vector. Normally we are representing the position vector with a small letter R. Suppose if we are consider another object Q at another point, then with respect to the same origin or same reference point, in order to represent the position of Q, we have to use the position vector OQ. And we can represent as R1 or R2 or R dash, any notation we can use. This is a position vector. In order to represent the position of an object with respect to a selected or a fixed origin, we are using this position vector. Okay. Then how we can represent this position vector in this vector format, that we can consider, and how we can represent this position vector. In order to represent the position vector, first we have to consider every vector. That means in order to represent any of the vector, we can represent that vector as the magnitude of that vector and the direction of that vector. A vector quantity means it has both a magnitude and a direction. So in order to represent any of the vector, we have to, or we require the corresponding magnitude of that vector as well as the direction. Suppose if you are considering a one-dimensional motion, then in order to represent a vector, suppose a vector A is considered, in order to represent this vector, we have to use the magnitude of that vector, A, and in order to represent that vector, we require the direction. In order to indicate the direction, the last class we mentioned about the unit vectors. In a rectangular coordinate system, we are using unit vectors that has only magnitude is unity or magnitude 1 and indicating a particular direction. And mainly the three unit vectors are using in order to represent the x direction, unit vector I or I cap is using. Then in order to represent the y direction, unit vector j cap is using. In order to represent the k direction, in order to represent the z direction, unit vector k cap is using. So here we consider this, suppose this object is moving along or directing along this x axis, then in order to represent that vector A, magnitude of that vector, then the direction. In order to represent the direction of that vector, we use this I cap. So magnitude into direction. And suppose if the vector B, we are considering the vector B, and that B is moving along this y axis, then in order to represent that vector B, the magnitude of that vector B into direction. If it is directed along this y axis, then in order to represent the direction of that y axis, we are using this j cap. Suppose another vector that is C, it is directed along this z axis, then in order to represent that vector C, the magnitude of that vector C into direction of z axis, we are representing with this k cap or this unit vector k. In this format, we can represent any of these vector. Any vector can be expressed as its magnitude and the corresponding direction. Then suppose if we are not knowing the exact direction, here we consider these I, j and k because we know the particular direction of that vector, exact direction of that vector. One is directing along this x axis, the other one is directing along this y axis, and the other one is representing along the z axis. Suppose if we are not knowing the exact direction, then in such a situation we can represent these vectors in terms of the corresponding unit vector, but we have to use an arbitrary unit vector. For example, if you want to represent this vector A directing in any direction, then in order to represent that one, we have to use this magnitude of that vector A into unit vector. Normally we are using an arbitrary unit vector, small letter n cap. That n may be, if the vector A is directing along this x-axis, that n becomes I. Then if the vector A is representing along this y direction, then that n, instead of n we can use what j. If it is along this z-axis, then we can use this k. Okay. So in any way, any vector can be expressed as the magnitude of that vector into the corresponding unit vector. Okay. Then next, how we can represent this corresponding position vector. Suppose this r, how we can represent this r, and this r can be expressed as what? This r has a particular direction, then a particular magnitude, and this vector is representing the corresponding OP is the position vector, or OQ is the position vector of second object, and this r, or instead of that one we can represent as OP. And how we represent this one? And both these has this x component and y component. The position of this P means it has a particular x component and a particular y component. X component and y component is there. So now to represent that one, we can use this what? This x component that directing along this, in order to represent that direction I cap, plus the y component is in order to represent that one we have to use this j cap. That is the representation of this one. If you are representing this OP as vector r1, then can be becomes write as x1i and y1j. Similarly, if you are representing this vector this OQ as r2, OQ, that is the representing vector r2, then it can be expressed as how? It's x2i plus y2j. In order to represent that direction, it is using that j cap. Okay, y2j is the notation. Then suppose if you are representing, now here we are representing it on the two-dimensional space or in a 2D space, so x component and y component is there. Suppose if it is in a three-dimensional space, then what will be in a three-dimensional space? In a three-dimensional space, x, y and z axis is there. So each vector has three components, x component, y component and z component will be there. Okay. Then next we have to consider the same situation here. If you are considering initially the position of this position vector is considered with respect to the fixed origin. In order to represent that position, we are using this position vector. The next we have to consider the displacement vector. How we can consider the displacement vector? The same situation here we are considering what is the particular two-dimensional space we are considering, then this x-axis and y-axis is considered. Then with respect to the common origin, initially at the time t, the object is at the position p. Then OP is the position vector at that corresponding time. Then after a small interval of time delta t, initially when the time is t, its position is at p. Then after a time delta t, that is we can represent it as the time t dash, its position changes to p dash. Then after delta t, its position changes to another point, that is p dash. Now in order to represent this position, we can use this vector OP dash. OP dash is the vector after a small interval of time delta t. Now due to this during this delta t time interval, the object's position undergoes a change. Whenever a position change takes place, what happens? The displacement is taking place. So here the displacement means from P to P dash is the displacement, and the straight line distance between that P to P dash, initial and final position, the straight line distance between initial and final position, that gives the displacement. Here the final position is P dash and initial position is P. So in order to find the displacement vector, we have to consider the final position, the coordinate of final position minus the coordinate of initial position. The final position is P dash, and the coordinate of that P dash we can express it as P dash. So it is x coordinate is x dash, then representing that I cap, then plus what is the y coordinate is y dash, then representing the direction it is j cap. And similarly the initial position is P, and the coordinates of P is represented such as x coordinate is x, then xi plus y j. Then displacement means we have to consider the difference of these position coordinates. So we have to consider this xi plus yj minus this initial position coordinate, that is the initial position coordinate means what it is xi plus yj. So subtraction between these two, that gives the final position minus initial position, that gives the what the displacement vector. The displacement vector that let us the displacement vector is what final position to initial position, that is from p dash, that position change taking place from this p dash to p, that is the displacement vector. P dash p is the displacement vector, and that is the difference. Then here I coordinates, we have to take and I coordinates common, so it becomes what it is x dash minus x into I unit vector plus what is y dash minus y into j, the direction or the unit vector j. This gives the displacement vector. So the corresponding displacement vector also have an x coordinate and a y coordinate. The x coordinate of displacement vector is this x dash minus x, and the y coordinate of this displacement vector is y dash minus y. So this is the displacement vector, and it is directed from this p to p dash. The position change is taking place from p to p dash, so the direction of this one is also along this p to p dash. Then that's about the position vector, and using the position vector we can find the displacement vector. Okay. Suppose if the path of that object, the position change is taking place along this kind of a curved path, that is not a problem, because we are already know that the displacement means it is the distance between the initial and or the straight line distance between initial and final position. So whatever may be the path followed by that particular object, we have to consider the distance between the straight lines distance between the initial and final position. So p dash and p, between p dash and p we have to consider. So this is a way to find the or represent in the displacement vector. Okay, whatever the magnitude and direction, here it is represented in two-dimensional space. So x coordinate value magnitude is there, that is x dash minus x. Y coordinate or this y component corresponding to that one is y dash minus y, that is the y coordinate of the displacement vector. And to represent the direction, we are using, in order to represent the x direction, the I cap is the unit vector. To represent the y direction, unit vector j is using. Okay. Now next we have to consider this addition and subtraction of vector. How we can add and subtract more than one vectors. So addition and subtraction of these vectors. For this addition and subtraction, this addition of vector is mainly carrying out two methods we are using. One is the graphical methods and the other one is analytical method. One is graphical method and the second one is its analytical method. In the graphical method, we are using the representation of that vector. The straight vector notation graphs are using, and using that graphical method we can add or subtract. One point here you have keep in mind, the subtraction of vector means actually we can carry out the subtraction with the help of this addition. How it possible? Suppose if we want to add two vectors, a and b are two vectors. If we want to add two vectors, then we are doing what? A vector a plus vector b. And same way, if we want to subtract this vector a minus b, and this a minus b is also carried out with the help of this addition operation. How? In order to subtract this vector b from a, we have to just add the vector, that vector a, plus the negative vector of b, taking the negative vector of b, then a plus negative of, how we can obtain the negative vector? Suppose this is vector b, then negative vector means just same magnitude but just reversing the direction, that gives the negative of that vector, then this is minus b vector. So just adding that vector, negative of that vector, that gives the subtraction result. Okay. So subtraction means just through the addition we can carry out the subtraction. How? Just taking the negative vector of one and adding that one, then that will give the subtraction result. Okay. Then in this addition process also two methods are we mentioned. One is the graphical method and the other one is the analytical method. Then the graphical method, mainly this graphical method follows one condition or this rule. One is the triangle law of vector addition or parallelogram law of vector addition and also a polygon law of vector addition. These are the three rules which we are using or law using for this graphical vector addition. One is the triangle law of vector addition, then the other one is or same, almost the same, but the procedure is different. The same operation, the parallelogram law of vector addition. Then one more is that is the polygon law of vector addition. And what is this triangle law of vector addition or parallelogram law of vector addition and polygon law of vector addition? That we have to next consider. Okay. Then what is mean by this triangle law of vector addition, then polygon law of vector addition or the parallelogram law of vector addition. Okay, that we have to consider. Then analytical method, after that we can explain the analytical method. Now we can consider this addition. First we can consider the triangle law of vector addition. The triangle law of vector addition, or first we can consider the triangle law of vector addition. The triangle law of vector addition means, suppose if you are obtain the two vectors, one is this vector, one vector is vector A, another one is, suppose this is a vector, that is vector B. These are the two vectors. Suppose we want to add these two vectors, then how this addition is carrying out? With the help of this triangle law. And for a vector, we have to consider two regions. One is the tail region of that vector and another one is the head region of this vector. The tail region, for every vector we can consider this as the tail region and this as the head region. Okay, for every vector we can consider this head and tail region. Okay, then in triangle law of vector addition means just arranging this vector head to tail. That means we have to consider the head of one vector and to the head of that one the vector, tail of the other vector we have to consider. Keep in mind that we are not possible to change the direction of vector, just we can adjusting these vectors. How? The head of one vector is connected with the tail of the other one. Okay, and in this situation these A and B vectors are given, then just adjusting that one means no need to change the magnitude. It is not possible to change the magnitude, just same magnitude. Then this is a vector A, and the vector B, we are not possible to change the direction of that vector, just adjusting that vector in the same direction and just joining that head of A is now joined with the tail of B. Now after this rearranging that one, we have to consider these two regions. That means the remaining section. What is that? We have to join the head of this B and the tail of this A. That gives the resultant of this vector. This region gives the resultant of that vector. Vector A plus vector B is given by this particular region. That means if we are available with the two vectors, then surely we can use this triangle law of vector addition. Just arranging that vectors, head of one vector is connected with the tail of the other one without changing the direction and magnitude, just rearranging that one, then join the head of one vector to the tail of the other one, then that side gives the resultant of that vector. This side now gives the resultant of that vector, vector A plus B. Okay, this is the triangle law of vector addition. Okay, there exist some limitations for these kind of graphical addition. One limitation here we can mention, that is, suppose these vector A and B are, suppose this direction is vector A and this vector B is in this manner, then it is not possible to use the triangle law directly. Okay, suppose this is vector A and this is vector B, how we can join? If we join this head to head or head to tail or tail to head, it is not possible to construct a triangle easily. So this kind of limitations are exist. Anyhow, in other situations we can use this triangle law of vector addition. Okay, then almost similar to this triangle law of vector addition, in another example also we can consider. Suppose if you want one more example, just we can consider another two vectors. Suppose this vector P and Q is suppose two vectors are considering vector P and Q. Instead of this A and B, suppose another two vectors we are considering. It's vector P and another one we can consider this vector Q. And how here we can use this triangle law of vector addition without changing this direction and magnitude. How we can use this addition here? Then just P is the vector P without changing the magnitude and direction. Here we arrange this P. Then head of one vector should be arranged joined with the tail of this other one. Then just consider the vector Q in this manner. Now head of this Q is joined with the tail of this P. Then the remaining part, but the open end we have to close that one. Then now this gives the resultant of that P and Q, the vector P plus Q. This vector gives the resultant of that vector. Okay, this is a triangle law of vector addition. Okay, the next we have to consider this parallelogram law of vector addition. After this triangle law of vector addition, next we have to consider the parallelogram law of vector addition. How this parallelogram law we have to use? The same way here also we have to consider the two vectors. Suppose this vector, two vectors we are considering, this vector A, then another vector, it is this vector B. These two vectors are here. And how we can use this parallelogram law? So parallelogram law, in order to apply this parallelogram law, first we have to construct a parallelogram by using the given two vectors. How it is? Just considering, just again rearranging or arranging these vectors without changing this direction and magnitude. This vector A, without changing the direction and magnitude, we have to arrange the other vector. But here the common origin we have, the tail and tail have to be joined. So in the second vector B, if we connected this tail and tail of that one, then this manner will be the vector B. Now vector A and vector B are arranged with a common origin or common tail points are connected in common manner. Okay. The next we have to construct it as a parallelogram. How we can construct it as a parallelogram? Just drawing another line parallel to B from the head point of this A. Parallel to B, draw a line from the head point of this A, and that is parallel to vector B. And another one we have to draw from the head point of this B parallel to A. That gives the parallel vector for this A. Now here we obtain the intersecting point. Then after this one, just joining that intersecting point with the origin. This gives the resultant of this vector A and B. This gives the resultant of that vector A and B. Suppose if you are initially we given two vectors, vector A and vector B, then just arranging that vectors in a common point, the tail regions are connected commonly A and B. Then after that we have to construct it as a parallelogram by drawing two lines parallel. One is parallel to the vector A starting from the end of this B, and another line we have to draw parallel to B starting from the head of this A. Then the intersecting point of that one is joined with the origin or that common tail point of that one. Then that gives the vector resultant vector A plus B. The same result we will obtain in case of this triangle law of vector addition also. Suppose here we apply this triangle law, what happens? This vector A is here. Then in order to construct it as a triangle, just join that one here. This is the vector B is joining at the end of that A. And this side, this third side gives the resultant of this A vector A plus B. The same, the vector A, vector B and the resultant. Here also this vector A. Instead of this vector A, this is similar to vector A and this is vector B, and this gives the corresponding resultant A plus B. This is application of this parallelogram law of vector addition. Both the vectors are connected in the common point, tail and tail are joined, then construct it as a parallelogram, then joining point connected with the tail and tail joint point, that gives the resultant. Okay, that is the parallelogram law of vector addition. Okay, the next almost similar to, if more than two vectors are available, then it is not possible to apply this parallelogram law and this triangle law of vector addition. In that situation we can follow this polygon law of vector addition. Here also the same limitations are existing. If the vectors are in parallel or in opposite directions, then the applications of these laws are not a suitable one. Okay. Anyhow, the polygon law of vector addition means suppose more than 3 vectors. Suppose this vector A, then vector B, then another vector, this vector C is the, then one more vector we can consider, this vector D. These are the vectors. Then how we can add these, the resultant of these vectors, how we can find. So without changing the magnitude and direction, we have to rearrange that one. This, now this is a vector A, then from that head of that one we are joining this vector B, this is vector B, this is vector A. The next day, without changing the direction, we have to consider. Then from this tail of this A, we can join that C, that is vector C. And now one more is that, what is that? This vector D. And how we can arrange this vector D without changing that magnitude and direction. We have to join that D also. Then just join in that vector D to this region. Then D is here. Then the remaining part or the terminal part, just join this part. Now this gives the resultant of this vector A plus vector B plus C plus vector D. This side will give the resultant of all these vector A plus vector B plus vector C plus vector D. That gives the trailing side of this one. Okay, this is the polygon law of vector addition. Here also the limitations are there. If the vectors are exactly opposite, all vectors are parallel or in opposite directions, then these kind of laws are not possible to apply. Okay, that comes the limitation of this kind of graphical method of vector addition. Okay, then along with these rules for this addition, vector addition, that is triangle law of vector addition, parallelogram law of vector addition, and polygon law of vector addition. Two more properties of vector addition here also we can mention. One is this: vector addition is commutative. Vector addition is commutative means what? If two vectors, vector A and B, are considered, then vector A plus B, that is similar to vector B plus A. One is the vector addition is commutative. Commutative means, that is a property of these vectors. The vector addition is commutative as well as the vector addition is associative. Commutative property means if we are considering the two vectors, vector A and vector B are considered, then this vector A plus B, that is similar to what? Vector B plus A. That is the commutative property of this vector. And the associative property means if you are considering three vectors, it's vector A, B and C are considered, then this vector A plus B plus C, if you are adding two vectors initially A and B, then add with that C, that should be equal to this vector A plus B plus C. That means if we initially add this C and D, then to that one if we add this A, that also gives the same result. That is, a vector addition is commutative and a vector addition is associative. Okay, and also you have to keep in mind this vector addition satisfying this property. Vector addition is commutative and vector addition is associative. Okay, already we mentioned about the subtraction. What is, in order to subtract a vector from another one, just we have to add the negative of that vector. If we want to add subtract A and B, then we have to add that A with the negative vector B or add the B with the negative vector of A. In that manner we can carry out this subtraction operation. Okay, that's about the vector addition and subtraction. Then for vector addition we mentioned the first we mentioned the triangle law of vector addition, then parallelogram law of vector addition, then polygon law of vector addition. Okay, and two properties of that addition, vector addition is mentioned. What is that? Vector addition is commutative and vector addition is associative.